Welcome to the basics of organic chemistry. I don't need your judgment.
Well, I'm judging anyway.
You know my kids are 5 and 7, and to them, I'm the coolest guy on the planet.
Harley was the only no leader.
Alright, we are starting from the basics. When we draw the homologous series, we draw it using a explicit hydrogen structure where the hydrogens are removed. In fact, in stage 2, you are able to draw your chemicals this way. The preference though is the stick form, or the skeleton form, which is a lot quicker. Now, where you see a little green dash attached to a carbon, that means that there's a hydrogen there. We don't display them all because it gets very, very complicated and crowded, especially for the longer molecules. I've only gone up to 6 carbons here. We can go up to 13. If you look on the blackboard that's at the back of the room on the corner, I've got the names for 1 carbon through to 13 on the board. I'll take a photo of that and stick it on the Edmodo comment under wherever the video for this goes. So starting from 1 carbon, and you can't just draw like a carbon with a stick, it doesn't work. You need to have a minimum of 2. We just write CH4, and that's known as methane. When you've got 2 carbons next to each other, they will bond through the centre with a covalent bond. 2 carbons, like each carbon's got to have 4 bonds. So you've got a carbon-carbon bond there, and everywhere else is surrounded by hydrogens, remembering that we're not drawing them. Where you've got a stick occurring, there's a hydrogen around each. So the formula for this is going to be C2H6. But if you were to draw it in the stick form, it's just 1 line. Now the end of the line represents a CH3, unless otherwise something is drawn there, like a chlorine or a double bonded O or something else, which comes later. Because what we do is we start off from these basic alkanes, and we start to build on top of them by adding things to them. That's where the names change. This is propane, because you've got methane, ethane, propane, 3 carbons, C3H8. 1, 2, 3, 4, 5, 6, 7, 8. Yep, and you can see here you've got 1, 2, 3 carbons. The next one is butane. 4 carbons in a row. 1, 2, 3, 4. Pentane. 5 carbons in a row. 1, 2, 3, 4, 5. Hexane is 6 carbons in a row. 1, 2, 3, 4, 5, 6. Now the key part of this name is it consists of 2 things. The part meth, which denotes how many carbons in a row there, and ane, which means that there's no double or triple bonds present. And that's, you can see that each of these are an ane. Ane. Same for heptane, which would be the next one, octane, nonane, and decane. So that's 7, 8, 9, and 10. Now, this is how you name them. And that would indicate how many carbons in the row and the fact that everything is single bonded. What we can have in these chains is double and triple bonds. So if I take, for example, you can't do a double or a triple bond with methane. So you can't have methane or methine because 1 carbon can't bond with more than itself. Like it's just got hydrogens, that's it. But once you get to ethane, you can actually have a double bond. So we could have a double bond between the 2 carbons, remembering each carbon has 4 bonds. So you can have a hydrogen off either side. This is now known as eth, which will indicate 2 carbons in a row, and then ene. Ene is the meaning of that there's a double bond. Propane, we can do a double bond with 2. So you've got C, bond, C, bond, C. Let's say we put the double bond there. You've got 1, 2, 3 bonds on that middle carbon, so you're going to have 1 hydrogen. And this one here is going to have 2, because it's got 2 bonds there and 2 off to the side. This is propene. There's no requirement to indicate that this is carbon number 1, because I could draw this differently. I could stick the double bond over here, get rid of one of those hydrogens, and make that. It's still propane. No matter which way you turn it, the carbon number 1 is going to be the carbon on the side which has the double bond. And that's how it works in the stuff. When we've got the homologous series, if you've got a double or triple bond, that's where the first carbon comes into it. So if we look at butane, this is where it can start to get a little bit more complicated. So we're going to do butene. 1, 2, 3, 4. Now I can put my hydrogens around them. So we've got butane there at the moment. Now I can put a double bond here, which is going to knock out 2 of the hydrogens. And this is going to be carbon 1, 2, 3, and 4. So this is going to be but-1-ene. Or 1-butene. If you're doing the crossword, I use this. This is my preferred, but both are acceptable for IUPAC nomenclature. Now we can also change this butene. We could put that double bond here. If you took the decision to put it around here, you could just rotate the molecule around and be exactly the same thing. You just start from carbon number 1, 2, 3, and 4. So that would still be but-1-ene. But if we take the double bond, thank you for the nods. I'm getting nods, like class is nodding, like making sense. If I now stick the double bond in the middle, alright, that's 1, 2, 3, I've got a hydrogen there. Alright, now this is different. That's a totally different molecule. This is called but-2-ene, or 2-butene. Again, this is my preference, and that's the one that's going to work in the crossword. If you don't know what I'm talking about with the crossword, I've got an 88 structure crossword where the crossword clues are chemical structures. So you're going to look here. Which one's carbon 1? Well, to be honest, you can treat either side as carbon 1. It depends on the substance itself. If, for example, I was to stick a chlorine here, then we would treat this as carbon 1. And if the chlorine was also here, then either of them could be carbon 1. See, this is what we're dealing with here. It very much depends on what's stuck to the chemical chain. Alright, next. Triple bonds. Let's put a triple bond in the middle. What the hell am I drawing there? 1, 2, 3, 4. Okay, so you look here, these carbons, they've already got 1, 2, 3, 4 bonds. So there's no hydrogen either side there, and then we're going to have 3 on this side. This is going to be but-2-ine. So we use Y-N-E to indicate a triple bond, and that is set ine. If I put the triple bond at the start, C bond, no, we've got to wait for that, 1, 2, 3, so that's going to have 1 hydrogen there, that's going to have no hydrogens, and then that's going to have 2, and that's going to have 3. This would be but-1-ine. But here's the thing, you wouldn't necessarily need to call that but-1-ine, because if you just wrote butane, as in just butane, where could the triple bond be? Well, if it's just butane, the only place it could possibly be is on carbon number 1. It's not allowed to be in the middle. If it's in the middle, you've got to introduce the number. So you do have the option to just write butane, but you're not getting it wrong if you write but-1-ine or 1-butane. That's also acceptable. So in summary, the homologous series: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, undecane, dodecane, tridecane. Single bond. That's an alkane. Ane. Double bond. That's an alkene. Ene. Triple bond. That's an alkyne. Ine. And And that's how you do the homologous series. Look at me, Christine, I'm dancing with the bamboo pole. Da, 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 da.